More review problems for force work and energy. Find the tension in all three ropes. What we have here, if we drew a free body diagram of that point right there, we would have one rope pulling down on that point. We would have a force right there and a force right there, and that angle right there is going to be 60 degrees. That angle right there is going to be 60 degrees. And assuming that all of these ropes are equivalent, we're going to have a tension in that rope, which is equal to a tension in that rope. And then what's going to be the tension in this rope? This one will just be 40 newtons, won't it? So that's one answer right there. Because the weight of this thing, M times G, is 40 down. And so if this thing isn't moving, mg being 40 downward, the tension upward here has to be 40. Now, the tension pulls up on the mass, but that tension pulls downward, you see in this picture on the left, at that point. Now, let's sum the forces in the up and down direction for that point. We've got tension times the, what would that be? Cosine of 60? Cosine of 60. And we actually have two of those. There's that tension cosine 60, and there's that tension cosine 60. So I'm going to put a 2 in front. Minus the 40 from that rope, and that should equal the mass times the acceleration of that point, but that point isn't moving, so the acceleration is 0. So what does this come out to be? T cosine of 60 is equal to 20. Does that look good? What's the cosine of 60? 1/2. Tension is 40. The tension in all three ropes is 40. Smiley face. Let's try one more. Here we have another mass at rest, and we want to know the tension in all three ropes. Here again, we can easily find the tension in rope number 1. Tension in rope number 1 is going to be 60 newtons because it is negating the effect of the weight here, 6 times 10. All right, now let's draw a free body diagram of this point right here. And at that point, we have 60 newtons acting downward. We have the tension from rope 3 pulling directly to the right. And then we have the tension from rope 2 pulling like that, where if that's 37 degrees, then this right here is 53 degrees. And that's the tension in number 2 there. Is that okay? 37 degrees, 53 degrees, that looks okay to me. Let's now look at this picture, and how about we sum the forces in the up and down direction? Well, that's going to be T2 times the cosine of 53, and that should essentially equal 60, because this T3 doesn't have an up and down component at all. So we only have the 60 that's acting downward, which has to be exactly offset by that tension multiplied by the cosine of 53. Well, let's see, the cosine of 53, isn't it 3/5? Because remember, with a 37, 53, 90 right triangle, that's a 3, 4, 5 right triangle. So I think this cosine of 53 is going to be 3/5. So what does that give us? 100. 100 newtons for the tension in rope number 2. All right, what about rope number 3? Well, let's sum the forces in the horizontal direction. Again, these are going to add up to 0, so they need to cancel each other. So now it's going to be T2 times the sine of 53, and that needs to equal tension number 3. Those are going to exactly offset. T2, we said, was 100. The sine of 53, can you do that in your head? The sine of 53 is going to be 4/5, 80. 100 times 4/5 is 80.